This is a demonstration of Navteq's automated mobile mapping collection system. The system is rigged to a vehicle and consists of multiple sensors. The sensors include 360 video collection, a rotating 360 LiDAR collection system for 3D data points, high-resolution multiple cameras, and a GPS IMU system for geopositioning the vehicle at all times. Here is an example of the 3D data points collected with the rotating LiDAR system. All points are collected in real time as the vehicle is traveling down the road. There's no need to stop to collect any data. 1.5 million points are collected each second, and the vehicle travels at typical posted speed limits. The LiDAR system collects 1.5 million points a second for a high-density, highly detailed point cloud. In addition, each point is registered with the reflectivity for easy location of lane markings and signs. Here's an example of the advantages of a ground collection system. This data would be impossible to collect from an aerial survey due to the overhanging structures. This is another example of the high-density 3D point collection system. Keep in mind what you're seeing here is all 3D data points, no surfaces or processing has been performed. This is just the raw data as it was collected. As you can see, you have all the storefronts, light posts, trees, pedestrians. You can see all the details on the facades. This is Union Station in Chicago. You can keep in mind this is all 3D data sets, so it's not just 2D facades. It's all 3D depth, so you can go behind objects. We're going to pick a couple data points to make some quick measurements. We'd like to find out how high the columns are at Chicago's Union Station. We find out that they're 11.3 meters high. In addition, every point is geolocated, so any point we pick we can find its latitude, longitude, and height above the ellipsoid. Navteq's mobile mapping collection system also records 360-degree video, such that we have a spherical image anywhere along the route, such that we can also look in any direction, including up and down. We then take advantage of the fact that we record both imagery and 3D data points at the same time and can superimpose the two together. And now, instead of just having intensity per point, we can overlay the two and compute an RGB value for every LiDAR point. So here is a color point cloud generated from both the 360 video and the 360 LiDAR collection. And again, these are all data points. Navteq is collecting this data to change the way maps are created and to create new advanced maps that represent the real world and objects that surround us. Some of the features you see in this video may be in your next generation map, such as highly detailed lane level markings, road signs, tree locations, signal locations, bus stop locations, pedestrian level details, and 3D building facades.